Hello everyone, this is grade 6, module 6, lesson 11, problem set. Number 1 says, 2 classes took the same mathematics test. Summary measures for the 2 classes are as follows. We have class A with a mean and mean absolute deviation, and then class B with their mean as the same and mean absolute deviation as something quite a bit higher. So A says, suppose that you received the highest score in your class. Would your score have been higher if you were in class A or class B? So when we look at this, we know that the mean is the exact same. They're both 78. But when we look at the mean absolute deviation, we see that class A has a smaller one, meaning all the scores are going to be similar to each other. So the variability is low, meaning the varying levels of the scores. We're probably not that far away from 78. That's what it pretty much means, that all the scores are hovering right around 78 because the mean absolute deviation is low. For class B, the mean absolute deviation is high, meaning scores could be very low compared to the 78, or they could be very high because there's such a stretch. So the variability is high, meaning there's many low scores and many high scores. There could be. So if I receive the highest score in the class, I would want to be in class B because the means are the same, but the variability, meaning mean absolute deviation, is higher in class B, meaning there's more of a chance it would be way above the mean. And there's my explanation right there. B says, suppose that your score was below the mean score. In which class would you prefer to have been? Explain your reasoning. Well, if my score was below the mean score, I would want to be in class A for the same reason. More or less, because the mean absolute deviation is only 2, it's showing that scores are going to be right around the mean. Meaning, if it's below the mean, even the lowest score for class A is going to be much higher than in class B, because in class B, this is the mean absolute deviation, meaning the distance, the average distance away from the mean is 10. Up here, the average distance away from the mean is only 2. So I'd want to be here because the distance away from the mean is smaller. And there's my explanation right there. Let's take a look down at 2. And this will be, we'll do some of these parts here. 8 of each of 2 varieties of tomato plants, Love 'em and Wonderful, are grown under the same conditions. The numbers of tomatoes produced from each plant of each variety are shown. A says draw dot plots to help you decide which variety is more productive. So I'm going to put in 2 of the same number lines, and I want to make sure that I count by the same, even though I can tell that with Love 'em, they're all hovering closer than in Wonderful, because I see the highest in Love 'em is 31, and the highest in Wonderful is 51. And I look at the lowest, and the lowest looks like it's 27 in Love 'em. And it looks like the lowest is 20 here. So we're kind of seeing that there's a huge range in Wonderful, and they're a little bit closer together in Love 'em. So when I draw these plots, I still want them to be the same scale, so I'm going to count by 5s for the number lines, because I want to get a true look at the data. So there's my drawings right there, at least for my number lines. So now I'm going to plot these in, and I want to keep them, and the reason why I didn't put the numbers on the top number line is because they're matching up with the lower one. So those are my 2 different dot plots. Now, in red, I'll do the top one. I'm going to plot those in. So I'm going to find 27, and I see that 25 is right here, based on the one below. So what I have to do is go over like 2 more, and I'm going to put a dot right above it. So now I'm going to do that for the rest of these. So there's my first dot plot, and I see I got 4 at 28, or 4 at 27, 2 at 28, 1 at 29, and 1 at 31. So I have 8 different scores in there. So now I'm going to do the same thing down below with Wonderful, and the first one I'll do is 31. So I come to 30, which is right here, and I'll go over to the 1, and I'm going to put a dot there for it. So now I'm going to start plugging these in. So there's my graph, or my dot plot for the bottom one. And what I'm going to do now is I'm going to write in my titles for these, or my labels for it. And I'll put number of tomatoes, and I'm going to abbreviate. You probably want to write the whole thing out just to help you out with that. But this is more for calculation purposes. So now, B says calculate the mean number of tomatoes produced for each variety. So now I have to take these, and to find the mean, I'm going to add up all of these. So each of these 8 numbers, and then divide by 8. So I'll add, then divide by 8. And for Wonderful, I'm going to do the same thing, add and then divide by 8. So I'm going to put my work off to the side here. So let's slide over, and I have to add up all of these, 27, 29, 27, 28, 31, 27, 28, and 27. So once those are all added up, we'll get 224. Now I'm going to divide that by 8 because there's 8 scores. That's how we find the mean of this. And what I'm going to end up with is 28. So that's the mean for Lovem. Now what I'll do is I'm going to add up all 8 of these numbers down below for Wonderful, and I get 256. And again, I'm going to divide it by 8 because there's 8 numbers or 8 pieces of data, and I get 32. So what I'm going to do now is I'm going to slide over here, and it says for B, calculate the mean number. The big question says which one produces more tomatoes on average, and that's going to be Wonderful with a mean of 32. And I have my work off to the side to show the other part of it. Now, C says, if you want to be able to accurately predict the number of tomatoes a plant is going to produce, which variety should you choose? The one with the smaller mean absolute deviation or the one with the larger? I'm going to talk this one out. It doesn't say which one do you want to have more. It says which one do you want to accurately predict. The one with the lower MAD is going to be easier to predict because it's telling you how far away from the mean the average piece of data is. So if we have a mean absolute deviation of 1, and we have a mean absolute deviation of 11, this top one I can predict is going to be within 1 either way. So 1 less or 1 over, I would predict from the mean. So if both of them had a mean of 32, I could say 31, 32, or 33, because that's kind of showing the average distance away from the mean. Now, if it's 11, it could be 21 to 43, because that's 11 below 32 and 11 above 32. Remember, mean absolute deviation is the absolute, so it's the standard deviation, but we find the absolute value, and it's the average distance away. So it could be 21 to 43. This one up on top could be 31 to 33. So that's kind of why I think the mean absolute deviation, the lower one, is easier to predict when you're looking at scores or predicting numbers of tomatoes and such. So the last one for D says calculate the mean absolute deviation of each plant variety. So what I'm going to do right now is I'm going to take this chart from up above and put it off to the side, and we're going to find the standard deviation, and then we'll talk about how to find mean absolute deviation. So there it is right there, and I'm going to go way off to the side here. And I'm going to blow this up, and I'm going to twist it so we can go sideways here with it. Kind of blurry, but we'll be able to work with it. So Lovum is, the mean is 28. So here's the mean. And I'll do the mean absolute deviation for one side, and you can do it for Wonderful. So if it's at 28, it means it's 0 away from the mean. So all the 28s are 0. If it's 27, it means it's 1 away, and it's 1 below, so it's a -1. So I'm going to do the standard deviation, and then I'll do absolute deviation. So the 27s are 1 below 28, so it's a -1 because it's 1 below. Which means if we had 29s, they would be 1 above. Which we have 1 of them because it's 1 over 28. So if I look now, I have 1 left, and that's 31, and that's 3 above, so that's a positive 3. And now if I take all the plus or the positive numbers, which is a 1 and a 3, that's 4, and I have 1, 2, 3, 4 negatives. So it should be 0 when you put the negatives and positives together. But right now, what I want to do is absolute value, because we have to find mean absolute deviation. So absolute value is just how far away the number is from 0. So -1 is 1 away. 0 is still 0. -1 is 1. Positive 3 is 3. 0, 1, 1, and 1. Now, to find mean absolute deviation, I add these up, because this is the absolute value. I have 1, 2, 5, 6, 7, 8. And then I have to divide by the number of pieces, or the pieces of data that I currently have on my page. So if I have 8 pieces of data, I'm going to divide 8 by 8 to get 1. So that means for Lovum, the mean absolute deviation is 1. Meaning the average distance away from the mean is 1. We know that our high score is 3 away. That's not 1 away, but it makes up for the ones that are 0. So if I were going to predict, I could predict 1 above or 1 below and be pretty close with my prediction. So what you'll do now is you'll go through and find the one for Wonderful, and your mean is 32, meaning 32 is 0. And then we got to find how far away each of these are. So just to start, if I'm going to 31 down here, that's 1 below. 20 is 12 below. 25 is 7 below. 50 is 18 above. And then you'll find the absolute values of these, which is just the distance from 0. So the absolute value of -12 is 12. Once you get those, add them up and divide by 8, and you'll have your mean absolute deviation. Hope this helps. Thanks for watching, and good luck on the rest of your problem set.